Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus physics SSC 2 unit number 11. Sound. Today we will discuss about SLO base according to Fbise requirement numerical problems. So today we will solve question number 17 to 20 in part 5. In previous part 4, we can solve numerical problem 13 to 16. Now we can solve 17 to 20. Numerical problems. Question number 17. Given statement is that what is the speed of sound at 15 Celsius in air? If the speed of sound is 332 meter per second at 0 Celsius, write the given data. Speed of sound V is equal to 332 meter per second and temperature T is equal to 15 Celsius. So we find that speed of sound at temperature T, that is equal to question mark. Using the formula to find the speed of sound at temperature T, so speed of sound at temperature T is equal to V naught. That means that speed of sound at 0 Celsius plus 0.61 multiplied by T temperature in Celsius scale. So using in solution, then we have in this case at V naught 0 Celsius is equal to 332 meter per second and change in temperature is 15 Celsius. So putting the values, then speed of sound at 15 Celsius is equal to Vt is equal to V naught plus 0.6 T. Then Vt is equal to 332 plus 0.61 multiplied by 15. 0.61 multiplied by 16, that is equal to 9.15. Adding 332 plus 9.15, that is equal to 341.15 meter per second. Now in other numerical 18, given statement is that find the range of wavelength for audioable sound if the maximum frequency is 20 Hz and its maximum frequency is 20 kilohertz. So we find the wavelength at both frequencies, minimum frequency and maximum frequency. So first of all, write the given data. Frequency of sound as minimum, that is equal to f1 is equal to 20 Hz and frequency of sound at maximum, that is equal to f2 is equal to 20,000 Hz. So we can find the wavelength lambda, then using the formula for the speed of sound or wave equation, that is equal to speed is equal to wavelength multiplied by frequency, that is equal to V is equal to f lambda. Then lambda is equal to V upon f. Now in solution for frequency of minimum sound, that is equal to f is equal to 20 Hz. Then lambda 1 is equal to V upon f1, that is equal to 332 divided by 20. 332 divided by 20, then lambda 1 is equal to 16.6 meter. And we can find the wavelength at maximum frequency for f is equal to 20,000 Hz, then lambda 2 is equal to V upon f, that is equal to 332 divided by 20,000. that is equal to 0.0167 meter. Now in question number 19, during the thunderstorm, thunder sound is heard after a 3 seconds of the lightning flash. Find the distance of cloud from the ground. Here speed of sound is 340 meter per second. So we using the given data, speed of sound that is equal to V is equal to 340 meter per second and time t is equal to 3 seconds. Now we have find the distance s is equal to question mark. Using the formula, distance is equal to velocity multiplied by time. So finding the solution, we know that S is equal to Vt. So we have in solution putting the values. Then S is equal to Vt, that is equal to 340 multiplied by 3. 340 multiplied by 3, that is equal to 1020 meter per second. Now in last numerical 20, sonar sound negation or ranging of system send ultrasound signal toward the seabed. It receives back after a 3.5.3 seconds. If the speed of sound in a seawater is 1550, that is 1550 meter per second. Find the depth of seabed. Now given data, speed of sound V is equal to 1550 meter per second and time t is equal to 5.3 seconds. Now we can find the distance s and depth d is equal to question mark. Using the formula, distance is equal to velocity multiplied by time, that is equal to s is equal to vt, and depth is equal to d, that is equal to s divided by 2, that is equal to the total distance of the half of the distance is equal to its depth. Now we can find the solution. S is equal to Vt. Putting the values, S is equal to Vt, that is equal to 1550 multiplied by 5.3, that is equal to 8215 meter per second, and we can find the depth d is equal to s divided by 2. Value of s is equal to 8215 divided by 2, that is equal to 4107.5 meter. Now this is the last numerical of this chapter. In next video with next lesson, best of luck.